Hey, good afternoon or morning, whichever the time may be. Today we're talking about math and significant figures. Yesterday we had talked about significant figures. We had mentioned that it is a form of communication, and it communicates how precise the measurements were. For any sort of measurement, we know that we are going to have some known values, and then we have to have our final value being an estimated value. And that's kind of a value that we estimate as the equipment users. When we are doing math, which we often have to do in chemistry, we're doing math with measurements, we need to maintain the correct number of significant figures to communicate to everybody, well, this is how precise we are. This is values that we actually know versus this is stuff that we're not sure about. And we do, there's two rules. One is for multiplication and division, and one is for addition and subtraction. You really need to pay the most attention to multiplication and division because that's what we're going to use the most. And that rule is relatively straightforward. The rule is that your answer can only have as many significant figures as your measurement with the least number of significant figures. And we'll explore that in a second on the next screen. For addition and subtraction, the rule is your answer can only have as many decimal places as your measurement with the least number of decimal places. And so let's explore this on this next screen. Let's look at some examples. So here we have, it's an addition. We have two measurements. These are volume measurements. I know this because the unit there is milliliters. We see 4.35 plus 9.125. Okay, so we were using, in this case, the setup is we're using two different pieces of equipment to measure volumes. The first one can only record to the tenths place, and then we estimate that thousandths place. The other equipment could record all the way down to the hundredths place, the hundredths place, and we estimate in the thousandths place. So I said that wrong the first time. So 4.35, the equipment knows down to the tenths place, and then we estimate in the hundredths place. 9.125, the equipment knows down to the hundredths place, and then we're estimating that value in the thousandths place. The first number there, we would say that has 3 significant figures, and the second, we would say that has 4 significant figures. Well, when we go to record our answer from adding these two values together, we cannot record the answer as 13.475. We have to round that and say, all right, well, our answer is 13.48 milliliters. And the reason that is because that 4.35, we didn't know that, the 5 in the hundredths place, we didn't know that for sure. We were estimating it. So then in our answer, we only estimate to the hundredths place to show how, confident we are in the number. In the next example here, we're doing some multiplication. We have grams, that's specifically 12.01 is the molar mass of carbon. So we have grams there, and we're saying, all right, grams times 1.3. The unit there, MOL, you'll see that a lot this semester. It means moles. We'll explore it more. But, we're just looking at this. All right, 12.01 times 1.3. Well, the first measurement there has 4 significant figures. The second measurement there has 2. So our answer, when I go to record our answer, even though the math will tell us, okay, well, the answer is 15.613, in chemistry, to communicate how precise and how confident I am in that value, I need to record my answer only in 2 significant figures. And so I am just going to say, I think I have 16 grams here. I'm not going to say 15.613 because I'm not that confident. I'm not that sure about my values, about my initial measurements. In this case, the measurements were 12.01 grams and 1.3 moles. I'm only, so confident about that 1.3, only to the tenths place. And so in my answer, I record only 16 grams. And that communicates to you as scientists, you as chemists, all right, Mr. Gould not super sure about this measurement. Next, we have another, this is a subtraction here, so we're going to follow the subtraction rule, which says, hey, least number of decimal places. That first value, 15.0214 meters, so it was a pretty precise piece of equipment to measure that length. But then the second value, 7.4 meters, we're only confident to the tenths place, right? And even in that tenths place, we were estimating. So it could be 0.5, it could be 0.3, right? And so because we could be off a little bit, a whole tenth either way, when I go to record my measurement, I'm not going to record it as 7.624. I'm just going to report it as 7.6 meters, just to the least number of decimal places. And now this last one, this is kind of a special case here. We have two measurements here, 780 marbles, and we're saying, you know, in this example, let's say we have 780 marbles and each marble weighs 15 grams, right? And we just know to that singles place there. One special thing about counting, when you have counting units, in this case marbles is a counting unit, right? I can't count fractions of a marbles. I can't count, you know, there's not going to be 780.1 marbles. No, it's going to be 780 marbles. End of story, right? Those are whole values. I can't mess up that count. And so counting units like marbles or people are considered to be infinitely significant. And so that I don't look at that 780 and I don't worry about how many significant figures are in that number. I worry about the measurement number. In this case, the measurement number is 15 grams because I can have fractions of a gram. I can have a decimal of a gram. And so because there's only two sig figs in 15 grams in my answer, when I go to record my answer, I will not record it as 11,700 grams, which is what you would get in your calculator if you put that in. I'm going to record that just as 12,000 grams. 12,000 grams has two sig figs, and so it's communicating this is how confident I am in that measurement. And now I know math-wise that really, really messes with people because, you know, my math answer says 11,700 grams, but then the answer that I'm recording is 300 grams more than what you thought. And that really, really messes with students all the time. But think about for a second, if we look at this 15 grams, well, we're estimating that singles place. So it could be, actually, we could be off by a whole gram, and the weight of the marbles could be actually be 16 grams. And so if we do 16 times 780, well, that works out to 12,480 grams. And so this is why we round the way we do. It's communicating how confident we are in our values.